Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn class 9th chemistry chapter types of chemical reactions and energetics, and this is our part 6. In this part we are going to learn factors that favor chemical reactions. Our first factor is close contact. No reaction takes place if the reactants are kept apart. For them to react, they should be in contact with each other. The contact can be increased by the way of powdering or grinding of reactants. Powdering or grinding of reactants. This increases the effective surface area of the reactants and hence the extent of contact increases. Consider the reaction of hydrochloric acid with large marble chips and smaller marble chips to understand. So, number of collisions are less when the surface area of CaCO3 is less. When marble chips are powdered or broken into smaller particles, the surface is increased, thereby increasing the number of collisions between the marble chips and HCl molecules. This increases the rate of reaction. Thus, more the surface area, more the rate of reaction. Reactants in solution state. When reactants are taken in a solution state, a closer contact is achieved more quickly by the reactant particles. Example, oxalic acid and sodium carbonate do not react on mere mixing. When water is added, both form a solution and increase the contact, favoring more reaction, which proceeds vigorously. Second is state of reactants. The chemical reaction depends upon the state of the reactants. The reaction is quicker if the reactants are in solution state. In the solution state, close contact is established more quickly between the reactant particles, leading to product formation. Example, sodium carbonate and tartaric acid do not react with mixing in solid state but vigorously react in solution state. Third is heat. Most of the reactions are brought about by heating the reactants together. Heating initiates the reacting particles to move faster and collide more frequently and result in product formation. Like N2 plus O2 on heating of 3600 degrees Celsius, 2NO nitrogen oxide is formed. Fourth is concentration. For some reactions, increase in concentration increases the number of collisions, resulting the product formation. Zn plus 2HCl gives ZnCl2 plus H2. Fifth is pressure. Some reactions take place only when the reactants are subjected to pressure. During this, reacting molecules undergo more number of collisions, resulting in more product formation. Example, N2 plus 3H2 gives 2NH3. Sixth is light. Some reactions take place only in presence of light energy. Example, oxygen present in the upper atmosphere gets converted to ozone by absorbing UV light. The reaction is written as 3O2 gives 2O3. Photosynthesis, the plants prepare carbohydrates in the presence of sunlight. The reaction is written as 6CO2 plus 6H2O gives C6H12O6 plus 6O2. Seventh is electric current. Some chemical reactions take place only when the reactants are subjected to electric current. When electricity is passed through the reactants infused or in aqueous solution, it gets dissociated into ions and gets deposited at all the respective electrodes. Example, when electrical energy is passed through fused sodium chloride, it gets decomposed into ions. These ions move to the respective electrodes and deposit. NaCl gives Na plus plus Cl minus. At cathode, Na plus plus electron minus gives Na. Metallic sodium gets deposited at cathode. At anode, Cl minus gives Cl plus electron. Chlorine plus chlorine gives Cl2 gas. Eighth is sound energy. A few reactions take place by absorption of sound energy. Example, acetylene decomposed into carbon and hydrogen when it is subjected to intense sound vibration. C2H2 gives 2C plus H2. Ninth is catalyst. A substance which alters the rate of reaction without itself taking part in the chemical reaction is called a catalyst. I'll repeat. The substance which alters the rate of reaction without itself taking part in the reaction is called a catalyst. Example, in the conversion of vegetable oils into vanaspati ghee, nickel is used as a catalyst. Next is topic of electrolysis. Substances are divided into two types on the basis of conduction of electricity through them. Substances which conduct electric current are called conductors, and substances which do not conduct electricity are called non-conductors or insulators. Conductors are again divided into two types: metallic conductors and electrolytic conductors. Metallic conductors and electrolytic conductors. Metallic conductors means these are the metals through which electric current can pass without any transfer or change in chemical properties of matter. Metals are the best conductors. Example copper, aluminium, etc. This property is not restricted to pure metal. It is also possessed by the most of the alloys of metals, carbon, certain solid salts and oxides. Electrolytic conductors, substances which allow the passage of electricity through their aqueous solution or fused states are called electrolytes. Passage or electric current results in transfer of matter and changes in concentration. Example fused salts, acids, bases and their aqueous solutions. Our next topic is distinction between metallic and electrolytic conduction. Metallic conduction, electrolytic conduction. What is electrolysis? Who was Humphrey Davy? Terms used in electrolysis. Why we observe the decrease in the size of electrodes. And Arrhenius' theory of electrolytic dissociation or ionic theory. I hope you have understood till this. Let us meet in part 7 with next topics. The topics which I announced now will be covered in part 7. I hope you have understood till this. Thank you for watching.